These next couple can be tricky to imagine. It's another one we looked at when we did cylinders, where you're supposed to take this flat thing and spin it until you get something that's actually three-dimensional. It's hard to picture, it's hard for me to describe when I'm not standing directly in front of you, but I'm going to do my best. We're going to find out what shape is made, and then we're going to find its volume. So we're taking this triangle, and we're supposed to be spinning it around the y-axis. So that's our up and down axis here. So you'll see part of it is already on my y-axis, so it's going to stay there. But like this corner is not on the y-axis. So it starts out on the right, but sometimes when I start spinning it, it'll be in front of my y-axis, and as I spin it, sometimes it'll be behind my y-axis. So you can end up picturing every little part, whether it's the corner or not, doing this spinning shape. But because it's a triangle instead of a rectangle, you end up getting a cone out of it instead of a cylinder. So anytime we give you something that's flat and we say, what 3D shape can I spin this in? The fact that I'm revolving it forces us to involve circles somewhere. So there are circles in this problem. That's what makes it a cone and not like a pyramid. So then when I look at this shape, since this is my biggest circle down here, I can see it has a radius of 2. And since the apex, the pointy part, would be up here, down to the bottom of the circle would be here, I can count that would be 1 square, 2 squares, 3 squares, 4 squares, 5 squares tall, which means the height of this pyramid is 5. So when we go to find our volume, 1/3 pi r squared h, I'm going to plug in 2 for my radius. I'm going to plug in 5 for my height. I'm going to ignore the first of those two things. 2 squared times 5, I'm going to combine. And then here I need to pause. 20 doesn't divide by 3. So if this was a regular class period in August, I'd make you make this into a fraction. We're not going to try that hard. I'm just going to say 20 divided by 3 is about 6.7 times pi. So if we want to get technical, that is very poor formatting, I guess you can call it. We don't mix decimals with pi, but it's summer school. I give you my permission to mix decimals with pi. So again, I took 1/3 times 20 to get the 6.7 and then just stuck a pi on it. Part B is the exact same flat shape, but on this one you're going to be spinning it around the x-axis, which means 2 of your corners of the triangle are already living there. This one is not. So if I start spinning that triangle from top to bottom to top to bottom, sometimes it'll go behind the x-axis, and sometimes it'll go in front of the x-axis. But you will end up getting another cone. It's just one that's turned sideways and really squished flat. So when I go to find my radius, so this is the big circle for the bottom, that's the diameter. I don't want that. If I go from the edge and stop at the center, that's our radius, which we already counted was a length of 5. If I start at the apex and go to that center, we get a height of 2. So 5 and 2 should be really familiar. We already dealt with a 5 and a 2. But it's going to still give us a different answer. Because 1/3 pi r squared times height, because this time the r is the 5, when last time it was the 2. So I'm going to combine 5 squared times 2. I'm getting another number that does not divide by 3. So 1/3 of 50 is close to 16.7. So I'm going to say this is a cone. Its volume in terms of pi is 16.7 pi cubic units. So you'll see it's bigger than the one we made last time. Not as tall, but it ends up being a lot wider.